We have now the physical control coating. So physical control is by coatings or painting. So the coating looks like that for a pipeline. It's a physical barrier to prevent contact with harmful elements like water, oxygen, solids, H2S, bacteria, sulfates, anything. So provides high resistance to current flow. Because these guys, remember when we did the exercise of the cathodic protection, we assumed the structure was bare steel. However, if we have a coating, we need to count for the coating factor or the coating efficiency. It means that the coating has basically high resistance to current. It means it is coating is not allowing the contact in between the steel to the electrolyte. Because, for example, cathodic protection send current through the electrolyte and protect. However, the coatings are not 100% impermeable. They have porosity. So through this porosity, the ions can still protect. So this is the factor that we count during the cathodic protection exercise. It's very important to know the factor at the time to design the cathodic protection system, because if we increase or we are adding too much current, the damage could be damaged. The coating could be damaged because we are adding too much cathodic protection. Those coatings, they are very basically used for complex or are could be used for erosional control, as those guys are very drag reductant. So these HDP liners are very slippery. So if we have something, then the stuff tends to move fast. The stream inside of the pipelines, for example, tends to move fast. This is example of high density polyethylene coating that is called in the industry as yellow jacket, and that is usually for 2 layers. And when we increase the temperature service, we add a 3rd layer, so it's like basically 3 layers. The coatings, they have specific characteristics. The coating must have they have a first application at the steel surface, and they prepare the surface, and they need to be prepared at certain standards. So they basically clean the steel to the white, is how they call it. It should be basically white, super clean, and then they apply the first layer of the coating, and then on top they start to apply in different barriers for different purposes. Some barriers are just basically to protect the internal barriers. Like, for example, the yellow jacket is intended to protect the black barrier, because the black barrier could be damaged easier. Now, the black barrier, it's an important one because if, for example, the coating or the system is for high temperature, something higher than 80, we need to have a special type of coating. Not every coating works always the same. So we need to have coatings for a specific application. We need to have coatings for high temperature, coatings for high pH, coatings for low pH, coatings for H2S, and coatings for specific aromatics. If the coating goes inside of the pipeline, it's basically painted inside of the pipeline, we need to count for the aromatic content. Because, for example, if we have methanol or some sort of alcohol inside, it can degrade the coating very easily. Even the 25% of aromatics is usually what is in the oil gas, so it's usually at that level in which the coating is resistant. Okay,